dear students. Now I am starting the second part of probability. Now we have got two. That is, one is P of A minus B is equal to P of A minus P of A intersection B. Actually, this is A and this is B. This part is called A minus B. The shaded part is A minus B. But we taken it as P of A minus P of A intersection. This part we are removing. The common part, this part we are removing. Equal to this one only. From A, we are removing the common part. So it is equal to P of A minus B. And one more thing. Suppose if two events, A and B, are mutually exclusive, no common points. This is A and this is B. Then P of A union B can be taken as P of A plus P of B. If A and B are A and B are mutually exclusive, means no common sample points. Mutually exclusive. Then P of A union B is equal to P of A plus P of B. But those two sets should not have any common sample points. That is the main thing. Now, by using these two, we will prove that next theorem, that is addition theorem on probability. A very important theorem. Let us go for that. Addition theorem on probability. Addition theorem on probability. Let us take the statement first. If E1 and E2 are two events in a random experiment, then the probability for getting either E1 or E2 is given by P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. అంటే E1 లేదా E2 లేదా రెండు కూడా జరగడానికి ప్రాబబిలిటీ ఎంత? దట్ ఈస్ ఈక్వల్ టు P of E1 plus P of E2 minus P of E1 intersection E2. ఫస్ట్ ఇందులో రెండు కేసులు కావచ్చు. E1 E2 మ్యూచువల్లీ ఎక్స్క్లూజివ్ కావచ్చు లేదా మ్యూచువల్లీ ఎక్స్క్లూజివ్ కాకపోవచ్చు. ఈ రెండు కేసులో మనం సెపరేట్ గా దీన్ని ఎక్స్ప్లెయిన్ చేయాల్సి ఉంటుంది. ఫస్ట్ కేస్ మ్యూచువల్లీ ఎక్స్క్లూజివ్ అని తీసుకుందాం. This is E1 and this is E2. E1, E2. Now, case 1. If E1 and E2 are mutually exclusive, E1 and E2 are mutually exclusive, then what is P of E1 union E2? This is P of E1. We know that it is equal to P of E1 plus P of E2. They are mutually exclusive. But it should be in this form. It should be in this form. How to write this in that form? That is equal to P of E1 plus P of E2 minus 0 I'll write. No change in the value. Now in place of 0, you can write P of E1 plus P of E2 minus P of E1 intersection E2. because E1 and E2 are mutually exclusive and E1 intersection E2 is a null set. So P of E1 intersection E2 is 0. Since E1 and E2 are mutually exclusive. So we have got P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. So this is proved in case of the two sets E1 and E2 are mutually exclusive. Now we'll go for the sets when they are not mutually exclusive. There is some common part. Then how to do that one? If E1 and E2, this is case 2, are not mutually exclusive. Now I will draw the diagram. This is first one is E1, this is E2. Now we have to write P of E1 union E2 is equal to union of these two sets means the entire thing, this whole thing is union. You can write it like this also, E1. First of all, I will write what is E1 union E2. E1 plus this part. E1 plus this part. What is that part? That is E2 minus E1. E1 union E2 minus E1. E2 minus E1. Means this shaded part plus E1 will give you E1 union E2. Now let us take the probabilities. P of E1 union E2 is equal to P of this one, that is E1 union E2 minus E1. Now these two sets E1 and E2, E1 is the white part, E2 minus E1 is the shaded part. They have no common part. Because they have no common part, you can write it whenever A and B have no common sample points, P of A union B is P of A plus P of B. By using that, you can write it as P of E1 plus P of E2 minus E1. Because E1 and E2 minus E1 are mutually exclusive. Whenever two sets are mutually exclusive A and B, P of A union B is P of A plus P of B. This is A and this is B. P of A plus P of B. And they are mutually exclusive also. Now we have to change this one. P of E2 minus E1. Now this is equal to, I told you previously, P of A minus B. A minus, this is A and this is B. A minus B is this part. P of A minus B is equal to P of A minus P of A intersection, A minus A intersection B. Sorry. P of A minus this part, the white part. So by using that one, you can write P of E2 minus E1 as P of E1 plus, now this is in the form of P of A minus B. That is P of E2 minus P of E1 intersection E2. Because of this one, P of A minus B is always equal to P of A minus P of A intersection B. Now it is in the form of P of A minus B. So P of A minus P of A intersection B. Now this is additional theorem. For addition theorem for the union of two events E1 and E2. Now there is a note also for this. Suppose if they are mutually exclusive, this is 0. P of E1 intersection E2 is 0. So then P of E1 union E2 is equal to P of E1 plus P of E2. Note, if E1 and E2 are mutually exclusive. P of E1 union E2 is equal to P of E1 plus P of E2, because P of E1 intersection E2 is equal to 0. Now, based on this theorem, I will explain one example also. That is, what is the probability for a non-leap year to have 53 Sundays? ఒక నాన్ లీప్ ఇయర్ లో 53 సండేస్ రావడానికి ప్రాబిలిటీ ఎంత అనేది డిస్కస్ చేద్దాం. వాట్ ఈస్ ద ప్రాబిలిటీ ఫర్ a non-leap year to have 53 Sundays? 1. 53 Sundays. 2. 52 Sundays. ఒక నాన్ లీప్ ఇయర్ లో 53 సండేస్ రావడానికి ప్రాబిలిటీ ఎంత, 52 రావడానికి ప్రాబిలిటీ ఎంత డిస్కస్ చేద్దాం. ఫస్ట్ నాన్ లీప్ ఇయర్ కి ఎన్ని రోజులువి? నాన్ లీప్ ఇయర్ ఇస్ ఈక్వల్ టు 365 days. That is 52 completed weeks plus 1 day ఉంటుంది. 52 వీక్స్ అన్ని వస్తాయి, కంప్లీటెడ్ వీక్స్ ఉంటాయి, ప్లస్ 1 day మిగిలిపోతుంది. ఆ 1 day ఏం కావచ్చు? ఇట్ మే బి సండే ఆర్ ట్యూస్డే, వెన్స్డే, థర్స్డే, ఫ్రైడే, సాటర్డేలో ఏదైనా కావచ్చు. సో రిమైనింగ్ డే మే బి Sunday or Monday or Tuesday or Wednesday or Thursday or Friday or Saturday. That means what are the possible outcomes for that day? There are 7 possibilities are there. That's why the sample space contains 7 sample points. That is n of s is equal to n of, that is Sunday, Monday, like that, Saturday. Total 7 sample points are there. Now let us consider the event E in which we get that Sunday to that remaining day is Sunday. Then only you will get 53 Sundays. Now E is equal to event of getting the remaining day as Sunday. If that remaining day is Sunday, then only you will get 53 Sundays in that year. That means how many possibilities, outcomes are possible in favor of this? Only one. Out of these 7, only one is in favor of that. That implies P of E, not P of E, it is N of E, is equal to N of only one sample point in that. 1. Now what is the probability for E now? That implies P of E is equal to N of E by N of S, which is equal to 1 by 7. So this is the probability for 53 Sundays in a non-leap year. Now in the same year, what is the probability for 52 Sundays? If that is not 53, it should be 52 only. So they are complementary events. So it is equal to P of E complement. Second, probability for 52 Sundays is equal to 1 minus P of E, equal to 1 minus 1 by 7. That is 6 by 7. This is probability for 52 Sundays. Now I will explain the same question for a leap year also. What is the probability for 53 Sundays in a leap year? Second question. This is first. Next. For a leap year. For a leap year, to have 53 Sundays, 1, 53 Sundays, and 2, 52 Sundays. Now, leap year is equal to 366 days. Leap year is equal to 366 days, which is equal to 52 completed weeks plus 2 days. 52 completed weeks plus 2 days. Now, the 2 days, now the sample space, the 2 days may be 2 successive days, either Sunday, Monday, or Monday, Tuesday, Tuesday, Wednesday, like that. So, yes, n of s is equal to here n of Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday. Here also there are 7 possible outcomes. 1, 2, 3, 4, 5, 6, 7. You will get only one of these 7. So, total possible outcomes are 7. So, that is equal to 7. Now, let us take E is equal to event of getting 53 Sundays in a leap year. 53 Sundays రావాలంటే ఆల్రెడీ 52 వచ్చాయి. ఇప్పుడు ఇందులో ఈ పేర్ వచ్చిన ఫస్ట్ పేర్ ఆర్ లాస్ట్ పేర్ ఈ రెండిట్లో ఏది వచ్చినా ఒక సండే ఎక్స్ట్రా వస్తుంది. సో దట్స్ వై హౌ మెనీ పాసిబుల్ థింగ్స్ ఆర్ దేర్ ఇన్ ఫేవర్ ఆఫ్ దట్, 2 possible outcomes are possible in favor of that. So n of E is equal to n of Sunday, Monday, and Saturday, Sunday. These outcomes are in favor of this event, required event. So that is equal to 2. Now what is the probability? P of E is equal to n of E by n of S. That is 2 by 7. This is for 53 Sundays. Now in the same question, we have to find out the probability for 52 Sundays also in a leap year. Second question, probability for 52 Sundays in a leap year. Now, if it is not 53, it should be 52 only. So, any one of those two will be possible. So, that is equal to 1 minus P of E. That is 1 minus 2 by 7 equal to 5 by 7. That is the probability for having 52 Sundays in a leap year. Next question. What is the probability of drawing an ace or a spade from a pack of well shuffled 52 cards? Now, if you draw a card from a pack of 52 cards, what is the probability for getting an ace or a spade card? You know that 4 aces are there in a pack of cards and 13 spades are there in the pack. Now let us take even. Let E1 is equal to event of getting an ace and E2 is equal to event of getting a spade. We have to get either E1 or E2. That means we have to use the addition theorem. That is P of E1 union E2. Here what is N of S? Total possible outcomes. You will get any one of those 52 cards. So N of S is 52 C1. That is 52 only. What is N of E1? There are 4 aces in a pack of cards. So I have to draw one from that. That can be done in 4C1 ways. So that is 4C1 is equal to 4. And N of E2. How many spades are there? 13 spades are there in a pack. So I have to draw one spade from that. That is in 13C1 ways. 13C1 equal to 13. Now, what is P of E1? N of E1 by N of S. That is 4 by 52. What is P of E2? N of E2 by N of S. That is 13 by 52. Now, there is one card in common. That is ace. That is an ace as well as spade also. What is that card? Spade, ace of spade. That is common card. Now, we have to find out. That comes in intersection. N of E1 is equal to number of aces with spade mark. That is equal to 1 only. So that is P of, this is E1 intersection E2. Number of aces with spade mark. That is 1. So P of E1 intersection E2 is equal to N of E1 intersection E2 by N of S equal to 1 by 52. Now let us find out the probability for E1 union E2. P of E1 union E2 is equal to E of E1 plus P of E2 minus P of E1 intersection E2. So this is first 4 by 52 plus 13 by 52 minus 1 by 52. That is 4 plus 13 minus 1 by 52. 17 minus 1, 16 by 52. You can cancel 4. That is 4 by 13. I will give another example. Suppose a problem in calculus. A problem in calculus is given to 3 students A, B and C, whose chances of solving the problem are 1 by 3. Sorry, here no C, only 2. Only 2 students A and B whose chances of solving the problem are 1 by 3 and 1 by 4. And 1 by 4. Now if they try independently, what is the probability that the problem will be solved? Here they are doing independently. They are not discussing with each other. Now what is P of A given? Is equal to 1 by 3. And P of B is equal to 1 by 4. Now, what is the probability for A to fail? Probability for A to fail is equal to 1 minus P of A. That is complementary. 1 minus 1 by 3, that is 2 by 3. Probability for A not to solve the problem is 2 by 3. Similarly, probability for B to fail is equal to 1 minus P of B is equal to 1 minus 1 by 4, which is equal to 3 by 4. Now let us find out the probability for both A and B to fail. Probability for both A and B to fail is equal to P of A bar intersection B bar. This is P of A bar, P of B bar. This is equal, because these two things are independent events. So this is P of A bar into P of B bar, which is equal to 2 by 3 into 3 by 4 into 3 by 4. 3 is cancelled. So 2 by 4 means 1 by 2. This is probability for both to fail. Now probability for the problem to be solved. Is equal to 1 minus this probability. 1 minus P of A bar intersection B bar. That is 1 minus 1 by 2 is equal to 1 by 2. So, the possibility for solving that problem is 1 by 2.